chemical sources of the electrical energy made a breakthrough in the world of technology. Nowadays, we use batteries everywhere, from mobile phones and laptops to power stations. Unfortunately, the batteries are far from being harmless to the environment. Most of them are not recycled and contain such elements as mercury, lead or cadmium, which are very dangerous for human health. Nevertheless, there are some types of batteries which do not release hazardous substances after their usage and are easier to recycle. Nickel metal hydride batteries are eco-friendly. Their development is also required for electric vehicles because of their reliability, power, and longevity. That is why many scientists work on the development of nickel metal hydride accumulators. Since the battery's efficiency depends mostly on the characteristics of electrodes, it's crucial to look for new materials that will optimize the performance and quality of nickel metal hydride batteries. In this project, we synthesized and investigated new electrode materials in the nickel metal hydride battery prototype. The materials were based on the compound gadolinium iron 2, doped by cobalt and nickel. Our goal was to improve the properties of this type of batteries, make them cheaper, more eco-friendly, and long-lived. For the synthesis of the alloys, each with a total mass of about 1 gram, we took metallic gadolinium, iron, cobalt, and nickel. The samples were prepared by arc melting of these components under an argon atmosphere at a pressure of 100 kilopascals. For better homogenization, the alloys were annealed in evacuated silica ampoules at 500 degrees for about 2 months and quenched in cold water.
If you found the one, you should never give her up. I think it's the way life changes when in love, yeah. I surround my soul with the positivity. That's why I don't worry about the things that I don't see, yeah. These days I don't worry about much. I think we should have some more fun. I still dream about the days when we were young.
Powder X-ray diffraction was the main method of the phase analysis. Electrochemical hydrogenation of the synthesized samples was carried out in 2 electrode spatial type cell. The alloy, with a mass of 0.3 gram, was powdered under hexane to avoid oxidation, mixed with an electrolyte, and put into the anode area of the battery.
If you found the one, you should never give her up. I think it's the way life changes when in love, yeah. I surround my soul with the positivity. That's why I don't worry about the things that I don't see, yeah. These days,
Nickel hydroxide, mixed with graphite and wetted by the electrolyte, filled the cathode area. A separator, made from the pressed cellulose, was placed between the electrodes to avoid direct contact.
who you love, baby. Take a moment to unwind, fix yourself and realign yourself with the world, baby. Breathe slow, baby, yeah.
First, we tested the battery with a voltmeter and confirmed that it was constructed right. Eventually, the prototype was charged and discharged over 50 cycles to the maximal possible saturation of the anode material by hydrogen. The amount of hydrogen deintercalated from the sample was calculated at discharge using Faraday's law. We examined the morphology of material's surface and compositions of material's grains by scanning electron microscopy. Finally, we compared the samples with cobalt and nickel to the binary compound gadolinium iron 2 and its derivative doped by zinc. The amount of absorbed hydrogen has increased, and therefore it has improved discharge time. Materials with cobalt and nickel are also more corrosion resistant and show better electrochemical capacity. The studied battery prototypes do not contain hazardous elements that make them easier to recycle. The obtained results can help predict the properties of the similar electrode materials, improve already existing ones, and develop new multi-purpose batteries.